Okay, the problem at 9.2 is to consider the convergence order of the secant method. So we first consider I would say a lemma or some background for the secant method, for the convergence of the secant method. Suppose we have a function f, that's a univariate scalar value function, and the C2. So this is what we require for to apply the secant method. And suppose x star is a local minimizer, and f double prime of x star is non-zero. Then suppose we have an algorithm that does these iterations, where this alpha k is some step size. So for secant method, this alpha k has a specific choice. But here for the part A, is just try to show the convergence of the sequence under the assumption that the alpha k converge. So the alpha k itself is a sequence converged to 1 over f double prime of x star. So here xk converges to, is supposed to converge to x star, and alpha k converges to this 1 over this f double prime. Okay, so now the question is, suppose that this is true, okay, meaning that the sequence converges to x star and alpha k converges to this as k goes to infinity. We want to show the order of this convergence is at least 1. Okay, it's superlinear, it's greater than 1. And then in the part B, we're going to show that the secant method, this result can be applied to the secant method to show that the secant method has some kind of convergence order. And in that case, we just need to realize that the alpha k is equal to this ratio that used in the secant method to show the convergence. So we'll see this one by one. So first, we need to show that the convergence order for the part A. We want to show the convergence order is at least 1, or it's superlinear. That means the limit of this ratio should be equal to 0. So to get the ratio here, the ratio is xk plus 1 minus x star, which is the distance between the new iterated xk plus 1 to x star. And this denominator is the old difference. So we want to show that this is equal to 0. So in general, remember that what we need to show is, to show the sequence has a convergence order of p, we need to show that this is equal to some fixed number, finite number. Then we can claim that the convergence order is at least p. Okay, so here if it's true for 1, then say here it's true for 1, you can show this 0, that means the order is at least 1, it's bigger, it should be bigger than 1. In that case, we call it the convergence order is superlinear. Okay, so let's just need to show this. Okay, that's all we need to do for this part A. Okay, so to show that, we look at the ratio here, and then the numerator, we can just substitute the algorithm. So the xk plus 1 is obtained from xk using this formula. So we just substitute that back in here. That's what we got for this part. And now let's just try to show this limit is equal to 0. All right, so to this end, we just need to make some small changes. So I combine these two, so that becomes this. And then because the x star is a local minimum, so it should satisfy the first order necessary condition, meaning that the f prime at x star should be equal to 0. And in that case, we just have this, add this extra term, but it's 0, so it doesn't change anything. And now we can put the parentheses, put the ratio inside the absolute value. So I just combine the numerator denominator, and then you can see these two cancel out and get just 1. And now I have the alpha k, and I have this ratio, this over this. Okay, so that's the second part, and that will be that. All right, now we need to show that this goes to 0. So you can notice that if xk converges to x star, then this, so we know that this will converge to 1 over, sorry, I should say this should be converging to star. So this is what we know from the question. And now on the other hand, we know this converges to this. I should say this x star as well. Okay, the reason for the second one here is because xk converges to x star. Okay, so so in this case, as k goes to infinity, the limit of this we should go to the f double prime due to the definition of derivatives. Okay, and that means the whole thing goes to 0. Okay, that means the whole thing goes to 0 because this goes to 1 over the f double prime, and this goes to just f double prime. So the product of them converges to has a limit of 1, and that makes the whole thing with a limit 0. Okay, to have a limit 0. Okay, so that's how we prove that this goes to 0, and this proves the first part, the part A, and showing that the convergence order is at least 1. Okay, so to use this in part B, we just need to realize that the second method is doing this iteration. Okay, where this part, we know that this came from the approximated reciprocal of f double prime at xk. So we don't want to really compute this in each iteration. Instead, we use this to approximate that. Okay, and so in this case, you can see we can think this as the alpha because it's just a scalar. It's the alpha k, and if we can show this alpha k converges to 1 over. So if we can show the alpha k converges to 1 over f double prime at x star, then we will have the result from the previous, the part A, right? So if we can show that, then we have the condition in the part A, and then we can use the result in part A, which says that this algorithm will converge with order at least 1, or it's a superlinear. Okay, so now the whole thing, the only thing that we need to do to show that this alpha k converges to that, or 1 over alpha k converges to f double prime of x star, just to put a reciprocal on each of them. Assuming that xk converges to x star, this is something we have to assume for the second method to work out, and also for this this is also part of the question in part A. It says that so suppose xk converges to x star. So we're also assuming that xk converges to x star, and we just need to show that in this case alpha k should converge to this 1 over f double prime, or in other words, just need to show this. Well, to show that, let's look at the difference of these two if this goes to 0. Well, on the one hand, alpha k is this ratio here, so the 1 over alpha k just swap the numerator and denominator, that's this. And I will keep this term. Well, by the mean value theorem, this ratio should be equal to f double prime of ck, where ck is some number between these two. Okay, so the ck should be some number between these two. But on the other hand, since xk converges to x star, the ck must converge to x star as well, right? Because the whole sequence converges to the point x star. Then if there's some point that's squeezed in between two terms in the sequence, then you'll be brought to the same limit as well. So we have that. As k goes to infinity, we'll show that we can show that these two actually are the same, or this actually converges to that. The reason is the f double prime is continuous since f is in C2. Okay, so the ck converges to x star, then the f double prime ck converges to f double prime x star. So we show that this should go to 0. Okay, with this going to 0, we have the condition from part A, and then we can claim that if you apply the second algorithm, and the sequence you generate which is xk, converge to the local minimum x star and also the f double prime at x star is non-zero, then we can claim that the second method will also have this convergence, superlinear convergence order.